Hello guys, I am Nidishri S. Bagalwadi, your science teacher, Sankalp Learning Solutions. So in the last class, we discussed regarding the concept of magnetic effects of electric current. And in the last class, we discussed regarding what happens when an electric current is passed through a circular coil and what will be the direction of magnetic field. And we also discussed regarding Ampere's experiment, right? So today we are going to discuss about the electromagnetic induction, the other most important concept of this lesson. Okay. We discussed regarding electromagnet, and now we are going to discuss regarding Fleming's left hand rule. So what is this Fleming's left hand rule? It shows us the direction of a force or a current carrying conductor in a magnetic field. So in a magnetic field, in which direction the current is moving, that will be given by Fleming's left hand rule. So what it says, Fleming's left hand rule says that if we hold the thumb, forefinger, and the middle finger, thumb, okay, and then forefinger, okay, and the middle finger of the left hand perpendicular to each other, perpendicular. This is 90-degree, and when you see this, this is 90-degree to this, right? Right? So Fleming's left hand rule. When you consider your thumb, forefinger, and the middle finger in perpendicular to each other, such that the forefinger points the direction of magnetic field, guys. The forefinger points the direction of magnetic field, and the middle finger points the direction of the current, and the thumb shows the direction of force of motion. As I said, the magnetic field exerts some force on the conductor, which makes the conductor to displace from its position, to change its place from its position. So in which direction the conductor moves, that will be indicated by the thumb. This is Fleming's left hand rule. Okay, the thumb indicates direction of motion of the conductor. The forefinger indicates direction of the magnetic field. The middle finger indicates the direction of the current. Okay, so this is done. I mean, this is given by Fleming's left hand rule. Okay, as we already discussed regarding electromagnetic induction. So in magnetic effect of electric current, what we learned, current produces the magnetic field. So in electromagnetic induction, we are going to learn the magnetic field produces electricity. Okay, magnetic field produces electricity. Okay, so here motion of a magnet with respect to, this is first discovered by Michael Faraday. Okay, motion of the magnet with respect to a coil produces induced current. So what happens? Now solenoid is taken, as you can see here. Okay, the solenoid is taken here. Okay, it is connected to the ampere. Sorry, it is connected to a ammeter. It is connected to a, this is an ammeter, right? So, and the magnetic field, the magnet is being passed through the coil. So when the magnet is being passed, what happens? The ammeter shows the deflection. Same way, when the magnet is passed in a reverse direction, the ammeter also shows the deflection in an opposite direction. So this shows that magnetic field is also inducing, is also producing electric current. That process is known as electromagnetic induction. Electroelectricity, magnet, magnetic, magnet, induction, production. Magnet producing electric current, that is electromagnetic induction. Okay, next. The next one is change in magnetic field produces induced current. There should be change in the magnetic field. For that, we are going to consider two coils of wires. Two coils of wires are taken and wound around a circular paper roll. So this is one coil. Sorry, just a minute. Fine. Yeah, this is one coil. This is other coil. So both the coils are wounded around the paper roll. Right. Next. Connect one coil to a battery. One coil is connected to a battery and one coil is connected to a galvanometer. Galvanometer is a device which shows a, what we can say, lesser amount of current, or we can say the current which is very less, like in terms of microvolt or millivolt, like that. Okay. So here, if current is passed through the first coil, the galvanometer needle shows a deflection in the second coil. So what happens if the current is flown in the first coil, the galvanometer in the second coil will show the deflection. If the current is disconnected, the needle moves in the opposite direction. If the current is not passed in the coil 1, the needle shows the opposite direction, right? This shows that current is induced due to change in the magnetic field. Due to change in the magnetic field, current is produced, they are saying. Next, we have Fleming's right hand rule. So what is this Fleming's right hand rule? It shows the direction of induced current. Fleming's left hand rule shows the direction of force of motion of a conductor carrying the current. But right hand rule shows direction of induced current. It states that thumb, forefinger, middle finger of the right hand should be holded in perpendicular to one another. When they are holded in perpendicular to one another, the thumb points the direction of motion. Thumb points the direction of motion of the conductor. Forefinger points the direction of magnetic field, and the middle finger points the induced current. Middle finger points the induced current. Thumb, that is direction of motion of the conductor. Forefinger, direction of magnetic field. Middle finger, direction of induced current. So this is given by Fleming's right hand rule. Next, the next concept we have is, just a minute. Fine. So when talking in our normal normal life, or whenever you're talking, when the elders are talking, you might heard that regarding the terms like direct current and direct current and alternating current. So a direct current means what? A current that always flows in one direction, which is called direct current. Alternating current, a current that reverses its direction periodically, which reverses its direction after some time in equal intervals of time. Most power stations in our country produce alternating current. Power stations means where the electricity is produced. That is called as power station. So it will produce alternating current which changes direction every 1/100 second, and its frequency is 50 hertz. One advantage of alternating current over direct current is that it can be transmitted over long distances without much loss of energy. But to transport the direct current, there will be much loss of energy. Next one is domestic electric circuit, then electric fuse. So regarding the uses, that is domestic uses of these concepts, we are going to learn in the next session. Until that, take care. Have a nice day. Bye-bye.